Okay, so if we look over to the sideboard here, here's where I keep my assignments, and here's where I keep what we're doing every day. So we'll be looking at the Algebra 1B, the second row. Monday, Tuesday, Wednesday we didn't have. Here's Thursday the 13th. Syllabus. Okay, we did that already. SWBA, does anyone know what that stands for? Student will be able to. Okay, so it's just saying by the end of the period, by the end of this lesson, you guys will be able to do whatever follows. So it's just like saying this is what our learning objective is. Student will be able to write algebraic expressions, which is our section 0.1. I called it chapter 0 because it's a review chapter. Okay. So the first thing I'm going to do on this, we're going to write our name. So my name is Mr. Costle, so I'll put Mr. Costle on there. Go ahead and do that on yours if you haven't already. Write your name. Okay. Now, for algebraic expressions, we have some important terms. So variables, you guys have heard this before. Variables are symbols used to represent unspecified numbers or values. So one thing I like to think about a variable is it's able to vary. It can vary. It can change. For example, 3 is always 3. 5 is always 5. But sometimes x is 3 and sometimes x is 5. It changes. Okay, it's able to vary. Now, what kind of variables have you guys seen before? X. What else? Y. Okay. Have you guys ever seen any other variables by alphabet letters? Okay, typically it's the alphabet, right? You see letters in the alphabet. It can be other things. You could use a smiley face if you wanted to. You could use like a star if you wanted to. It can really be any symbol. We just most often use the alphabet because it's a little more simple. Okay, it's a little more straightforward and it's common. So you can use the others, but we typically just use the alphabet. An algebraic expression. Does anyone know the difference between an expression and an equation? Okay, Emily? An expression, you don't solve it. That's part of it for sure. Yeah. Anyone else have any more on that? Thank you, Emily. Expression versus equation. You don't solve it. What else? Emily? One of them has the equal sign. Which one has the equal sign? The equation. Yep. The equation has the equal sign, okay? But the expression does not. Okay? That's why we can solve an equation because it has an equal sign. Okay? So here's some examples of some algebraic expressions that consist of one or more numbers or variables, along with one or more arithmetic operations. So an example could just be 3. 3 is a number. It's one number as an expression, algebraic expression. It could be x. It's a variable. One variable is an algebraic expression. It could be 4xy. They're multiplying together. There's 3 different things multiplying together, but that's an algebraic expression. You can have 2x plus 5. Have addition in there. It's an algebraic expression. Or you could have something like 3x squared minus 5x plus 4. That could be an algebraic expression. Okay. And these are just some random examples. They really could be anything. Now, if we have factors, factors are quantities that are being multiplied. They're quantities that are being multiplied. So 4xy, 4 is a factor, x is a factor, y is a factor. Don't write this part down. If I have 4 times 3 is equal to 12. 4 and 3 are factors. 4 and 3 would be factors there, okay? So here we have 4 and 3 are both factors. A product is the value of quantities being multiplied. It's your answer to a multiplication problem. Okay, so it's the value of whatever is being multiplied. So the product here would be 12. So 4 and 3 are the factors, they're the ones multiplying together, but 12 is our product, it's our answer. Power would be an expression like x squared. In the expression x squared, 2 would be your power, and x would be your base. Okay, you guys have seen those exponents right before. You've seen that. So if I have these in symbols here, how would I put this into words? What would you say that is if you were to describe it to someone? Okay, Aiden? Oh, you don't know? Tobin?
3 to the power of 1.
3 to the power of 1. Okay? Another way you can say it is 3 to the first power or 3 to the first.
Yeah.
Either one is they mean the same exact thing, right?
Yep.
Yeah. So 3 to the power of 1, 3 to the first. And what is 3 to the power of 1 mathematically? What is that?
3.
Just 3. Very good, Tobin. So it's just 1 3 is what it's saying. So the exponent tells us how many of the base there are. So what would this next column be? Or this next row be, okay? Tucker?
3 squared.
3 squared, okay? Some of you might know it as 3 squared. Some of you might say, oh, that's 3 to the second. Some of you might say, oh, that's 3 to the second power, or 3 to the power of 2. Any of those are okay. So 3 squared is just fine. What does 3 squared mean? Tucker?
3 times 3.
3 times 3. It's 2 3's being multiplied together, which is what? 9. Very good. 9. Okay. So 3 squared. 3 to the power of 2, or 2 3's multiplied together. Okay, and what would that last row be? Okay, Tucker again?
3 cubed.
3 cubed, okay? Also, you could say 3 to the third, 3 to the power of 3, 3 to the third power. And then what would that mean mathematically? How many 3's do we have multiplying together here? Lainey? 3 of them, yeah. And what is 3 times 3 times 3? 27, very good. Does it make sense? Okay. Trying to recognize voices even when I don't see you, okay? So, trying to get there. I'm going to be wrong a lot. Questions on this? No. Okay. So right below this, something that throws us off a lot in math is word problems, right? A lot of us see word problems and we instantly kind of freeze up or hesitate thinking, this is going to be harder. It's going to be tougher, okay? I think a lot of the challenge with word problems is just knowing what we're trying to even do. Is trying to figure out what is this even saying. So I have here a word bank of 12 common phrases we see in words and what they mean in math. And so we're going to put them into these 4 different operations: addition, subtraction, multiplication, division. So does anyone see up here one of them? Raise your hand if you see one of these 12 and you're like, I know which operation that means. Okay? Aiden, what are you thinking?
Times is multiplication.
Times is multiplication. You guys can go out and cross out times and put it in the multiplication box. You might see 4 times 5. Means you're multiplying and you get 20. Tobin.
Product is division.
Not quite.
Multiplication.
Product is multiplication. So if we say the product of 2 numbers, we're multiplying those 2 numbers. Okay? Maddie? Not quite. You want to take a stab at another one? Take away subtraction. Very good. Take away subtraction. If I have 5 apples and I take away 2, you're subtracting 5 minus 2. Okay? And we want to have another, well, they want to guess. Okay? Emily? Split up is division. If I say I'm going to split you up into 2 groups, I'm dividing the class in 2. Okay? Anyone else want to take a stab at one of these? Okay, Tobin.
Less than is subtraction.
Less than is subtraction. Now, less than's kind of a weird one, guys. Just a heads up. Less than's kind of a weird one. Because if I say I have 4 less than 10, how many do I have? If I say I have 4 less than 10, how many do I have, Aiden?
6.
6. Now, when I say 4 less than 10, which number did I say first? 4. But is it 4 minus 10? No, what was it? 10 minus 4. So be careful, that one's tricky, okay? You'll see that later. It's kind of tricky. So when you see less than, heads up, kind of tricky, okay? Anyone have another one for us? Maddie? Increased by is addition. The amount of time in the classroom has been increased by means you're adding time to the class, okay? Maddie? No, not quite. Lainey?
Quotient is division.
Quotient is division. So quotient is the answer to a division problem, kind of like product for multiplication. So if I say the quotient of 2 numbers, I'm asking you to divide the 2 numbers. Okay? And we have another one. I think we have 4 of these left. Decreased, difference, more, and of. Emily? Difference is subtraction. If I'm asking for the difference between 2 numbers, okay, if I'm asking for the difference of 2 numbers, I missed a few when I was talking. I'm asking you to subtract them. So if I say the difference of 5 and 4, I'm wanting 5 minus 4. Okay, Emily again? Did you have one or were you not raising it? Sorry. Anyone else? Tucker?
Decreased is division.
Not quite. Not quite. Let's think about what was increased. Addition. And are increase and decrease opposites? So what's the opposite of addition? Subtraction. So decrease is going to be subtraction. The amount of people at lunch has been decreased. The amount of people in the cafeteria for lunch has been decreased. It's less people in the cafeteria now because we have more people in the gym. Okay, so we have more of and some. Okay, Maddie? Not quite. Not quite, sorry. I love that you're trying though. I love that we're keeping trying. I love it. Love it, love it, love it. Lainey?
More is addition.
More is addition. We need 3 more pizzas. You're trying to add 3 pizzas to your total number of pizzas. Okay, we need 3 more. You're going to add 3 more. Okay? So we have of and some left. Anyone have any guesses on these 2? Tobin?
Sum is multiplication.
Not quite. Some is not multiplication.
Division.
Okay, no. Emily, what are you thinking? Nope. We have 1 more to guess though. So it's not subtraction. Aiden?
Division.
No, not division. No, what is it? Tobin?
Addition.
Addition. If I'm saying the sum of these numbers, we're adding them up. Okay, we're adding them up. Okay, the sum of the numbers, we're adding them up. So that takes us to of. What if I said I have 5 groups of 4? And if I have 5 groups of 4, how many people do I have in total? What if I change the numbers? I have 2 groups of 3. I have 2 groups of 3 students. How many students do I have? 6. How'd you get there? Multiplied. So of is multiplication. Very good, very good. Of's kind of a weird one. We don't think of it often, okay? But if we have of, it means we're multiplying, okay? So this is going to be a very handy chart for us. So look back when you have a word problem or an algebraic expression like we're going to have here next. To know what in the world are we doing here, okay? Look for the key words to know what operation we have. And we're going to translate words into math. So now we're going to practice taking these words and making it an algebraic expression. So if I say 5 less than a number, we're going to try and turn this into an algebraic expression. Lainey, you have a guess on this one?
X minus 5.
That's exactly right. X minus 5. Lainey, how did you know it was subtraction?
Less than.
Less than. Less than told Lainey, hey, this is subtraction. If we go back to our table, we see it under there. Now, Lainey did a great job, too, of making sure she did the X before the 5. Because remember, less than was our funky one where we switched the order, okay? Less than was the funky one where we switched the order. Now, Lainey also did another good thing here, where when we have a number, she just put X. It doesn't say what that number is. It's not saying it's 5. It's not saying it's 10. It's not saying it's 16. It's just saying any number. So we don't know it, so we call it a variable. Good job, good job. So whenever you see a number, that means a variable. You guys might even want to write that up here. If you have a number, that means you have a variable. Okay, so if you just see the phrase a number, it means you have a variable. Okay, and unless it says a certain one, you can use whatever variable you like. Question on the first one. Danked open liddy. Okay, number 2. 9 plus the product of 2 and the number D. 9 plus the product of 2 and the number D. Aiden. Aiden, can you put that away?
Sorry,
Okay. Gotcha.
Sorry. I thought it was my mom. I thought it was
Gotcha. Oh, okay, that makes sense. I thought you were answering the question. I was like, you were like right on. That makes sense now. Okay. So does anyone have a guess for 9 plus the product of 2 and the number D? Okay, Emily, what are you thinking? 9 plus 2D. Very good. That's exactly right. So 9, number 9, plus, adding, plus sign. Product means we're multiplying. What are we multiplying? 2 and the number D. So 2 and D are multiplying together. And that's our answer, okay? Now, Mr. Kossel, do we need parentheses here? Do we need to have these here to make sure we do the multiplication first? No, because doesn't multiplication come before addition anyway? Yeah, it does. So you don't need parentheses here to tell us to do that first, because we would already do it first. Aiden.
We only need parentheses if there's 2.
Yeah, sometimes if there's multiple multiplications, sometimes you need to know which one to do first, or a lot of times if you're doing addition and multiplication together, or subtraction and multiplication, or division with those, you might need parentheses. We'll talk about how we know parentheses happen in here. Now you could also do 2D plus 9. That's the same thing, because addition, we can do it in any order, okay? Now, this has the 9 first, so we put it first, but it doesn't have to be, okay? Number 3, 2/3 of the original volume B. 2/3 of the original volume B. Do we see any words there that appear in our chart? Okay, Tobin. Of. What does of tell us we're doing?
Multiplication.
Multiplication. So, we know we're multiplying. So now our question is, what are we multiplying? What 2 things are we multiplying together? So we go back to our sentence and it says, what are we multiplying together? Okay, Tucker?
2/3 of B.
2/3 into B. So it is 2/3 times B. And that's all we have for that one. Okay, so of would be the multiply, and then we just look around the sentence and say, okay, well, what are we multiplying? Questions on that one? Okay. Now, I don't think you guys have this here. It's a blank. So go ahead and write in 3/4 on number 4 there. It's a blank. It's a little bit longer. The product of blank and A, it should be 3/4. And it is raised to the 7th power. And what do we notice is different about this compared to our others? Tucker. It has a comma. And it says the comma is important here. Okay, we're going to talk about what that means in a moment. So, does anyone have any guesses on this one? Product of 3/4 A raised to the 7th power. exactly right. 3/4 parentheses to the 7th power. Okay? So that comma means that we're doing parentheses. So comma will equal what we're doing. Let me rewrite that. So comma will equal parentheses. So in the English language, ignore the commas that showed up that I need to get rid of right now. So a comma in the English language tells us to pause. Okay, it's saying pause. Okay, it's like a period is a longer pause. A comma is a small pause. So it's saying the product of 3/4 and a raised to the 7th power. Now, if someone's pausing when they're saying something, okay, that usually means that you're supposed to do that first and then keep going. That's what it's telling us here. Do this multiplication first, then raise it to the 7th power, okay? If we don't have these parentheses here, what ends up happening is you take a to the 7th power and then you multiply it with 3/4. What we want, according to this, is to multiply and then do the exponent, okay, because of the comma. Any questions on that? Okay, so, excuse me. So I'm actually going to end it here for now, okay? I'm going to end the notes here for now. We have a little bit more in this section. We're not going to worry about that today, okay? Hopefully you guys are okay with that. I'm going to pass out homework, and instead of doing the full assignment, since we didn't do the full notes, we're going to do parts of it, okay? We're going to do about half